So I'm going to cover a couple of reports on net zero for the defense sector. The idea is that these are not sectors that are going to go away anytime. It's not like everybody is going to say, well, defense is emitting too much, so we must scale down. If anything, countries only keep building military forces, and there is always some tension between countries. Even as everybody is getting richer, China is growing, India is growing in economies. US of course is rich, Europe is rich, Russia is doing its own thing, Middle East. So militaries are going to be around forever, and then you want to worry about sustainable development, net zero, global warming targets and all this. So are we going to just say militaries have to get to net zero as well because we cannot get rid of them? And there is another angle to it that I'll report elsewhere. So keeping that in mind, this is a report from Roland Berger, Defense Zero. It says Volume 1 Military Emissions and Potential Solutions. I haven't managed to find Volume 2 yet. So if somebody knows about it, let me know as well. What is the executive summary? Between 1% and 5% of global CO2 equivalent emissions are estimated to come from military and defense industry activities. This is according to recent studies by different stakeholder groups. So this is kind of a tunnel vision on carbon, and say we look at everything as carbon and decarbonization, and not, what is the impact if we start to move towards peace, for example, but that's a very different topics. At Roland Berger, our calculations suggest that the defense sector releases to the atmosphere emissions on the order of 500 megatons to 1 gigaton of CO2 equivalent annually, implying that it contributes between 1% and 2% of the global anthropogenic emissions. Of this sum, approximately 65 to 70% stems from the operation of military platforms and 30% from stationary assets, with the remaining share coming from the supply chain for military equipment. Okay, so military operations themselves, or military operations of military platforms, is putting out 65 to 70% of this contribution, and 30% from stationary assets, bases and ports and other things. Part of these emissions are sequestered by the vast amounts of land owned by the military. Typically, defense sector owns lots of land across the country, and they tend to maintain good vegetation, so you can see that as a net sink as well. In this study, we investigate how emissions from assets owned by the defense sector, both mobile and stationary, aggregate to produce the overall footprint and emissions profile of militaries based on the mix of assets owned by the armies, air forces and navies. So we consider all components of the defense when we say militaries. We estimate that air forces are responsible for 20 to 25% of the defense emissions, navies for 30 to 35%, armies for another 30 to 35%. Okay, so air forces fly a lot of missions, and flying is typically very expensive, but then navies are moving around in ships and doing lots of the things, and armies have lots of people, lots of land-based assets that also contribute. So navy and army are contributing about equal parts, and the rest comes from air force. So other branches of militaries add up a little bit as well. Then we break down emissions from air, sea and land platforms to identify the contributions of supply chain, which is about 3%, operations, which is 97%, showing that the number of active platforms and how they are used are the main drivers of military emissions. Having this kind of inventory is very important, because then it's easier to identify the levers where you can begin to reduce emissions. And then there is net zero, which has got a long way to go anyways for everybody, not just for defense. So here are some headliners. The defense sector generates 1 to 2% of the global emissions. The operation of more than 300,000 military platforms across land, sea and air domains contributes to the sector's emissions. As an executive summary, further we consider ways forward for the defense supply chain, including the implications of design on future emissions from the operation of platforms, which are massive, as shown by the 30 to 50% fuel and emissions reduction achieved in fighter aircraft with the introduction of composite material for aerostructures, and the potential to optimize material production and reduce the embodied emissions of military platforms through circular approaches. So it's not that militaries are trying to reduce their carbon footprint when they go after composite materials for aerostructures. It is that they want them to make as light and as fast as possible so that they can fly, and they want to keep their fossil fuel consumption low and refueling, etc. All kinds of design factors come in, but the co-benefit is that the emissions are reduced as well. This is the first volume of a series of studies in which we will investigate how armed forces and their supply chains can reduce their climate impact, not only without compromising their operational effectiveness, but also becoming more efficient and effective in a net zero world. So we are saying, go on, keep up your militaries and war machines, but try to be net zero. Okay? But maybe we will all start fighting wars with drones and robots, and then we will go to net zero in a very different way. So as long as you are not worried about stopping the wars, you just have to worry about how to make militaries net zero. Right? The challenge of understanding global defense emissions. So they will have a series of reports which I will track and add additional points as we get the reports made available online. Understanding the emissions footprints of the defense sector is a critical step to defining a strategy for mitigating emissions and other impacts. So you need levers. So lack of widespread reporting. No military is going to tell you their operations, their assets, their emissions, and so on. So obviously transparency is not going to be easy. Heterogeneity of armed forces. Obviously they operate in air, sea, land platforms and facilities and land, and they have satellites flying around, and they use people to do their crowdsourcing of spy. Obviously militaries will rely a lot on intelligence, and a lot of it will be crowdsourced as well. So how they actually spend the resources and the scales, compositions and utilizations, etc., are not easy to track in terms of their carbon footprints. And restricted access to operational data. No military is going to give you their supply chain details, their total consumptions of material and fossil fuels and so on. If you live near an Air Force base, you will see lots of sorties flying around all day, and they are obviously training, and they have to remain battle ready. So they have, they cannot sit and wait for a war. They have to keep on having exercises, mock drills and so on to be ready. Everything costs fossil fuels, energy, and causes emissions. A method to estimate global defense emissions. Roland Berger has developed a bottom-up method to estimate global defense emissions as an aggregate of three elements: emissions from mobile military platforms across life cycle stages, emissions from the other military assets that are stationary, and emissions sequestered by the land owned from the armed forces. So I won't go into the details, but there are ways in which they do these things. Okay, is there any main point I want to make here? Okay, emissions from military platforms have two main components: production and operation. The first refers to embodied emissions in the platforms as a result of all the processes that take place in the value chain of their production, from raw materials extraction and processing to manufacturing and logistics, to deliver the final product to armed forces. And there are other details. Operational emissions of these assets are calculated by applying platform-specific models which take into account specific fuel consumption and performance parameters derived from Roland Berger's project experience and other expert inputs to the output of the third-party proprietary databases of in-service military assets. So Keeping in mind the difficulties of getting the data, you have to do the best to model the emissions based on what data you do get. Emissions from stationary assets, sequestered emissions, they are estimated based on military land ownership data, land sequestration profiles, and sequestration rates based on the scientific literature. So stationary assets, of course, include military bases, ports, administrative buildings, research centers, etc. And they are location-based approach. That there are location-based approaches that consider these things. But you can be sure that each country is tracking other countries' military assets using satellites and drones and so on. So they will have a good sense of all these things, but again, they are not going to release it. They are going to try to hold on. They will try to hold on to it for operational advantages, right? So our model aggregates emissions from military platforms from other stationary military assets and emissions sequestered by the land owned by the armed forces. So the defense zero model structure is looked at it this way. The magnitude of the problem and main emissions drivers. These are the levers you want to have in mind. Defense generated over 500 million tons of CO2 equivalent in 2019, accounting for 1.1% of the total global emissions. We already said how they are distributed, and basically you want more than 500 million tons of CO2 equivalent generated by armed forces globally. Approximately 1/3 is likely to be sequestered by the vast amount of land owned by the military, so 2 to 3% of the world's total land. 2 to 3% of the world's total land is owned by militaries. Okay, that's how much countries value their defense. So it's not like everybody can step back, step down from the wall and put down the guns. They're just going to stay ready and have the gun pointed at each other, which is basically contradictory to the entire idea of sustainable development, but let's leave it there. So here is a way to think about, this is a big figure, so I've cut it into two pieces. So here we looked at the model aggregates emissions, etc., and this is armed forces supply chain operations and stationary assets produce 520 million ton CO2 equivalent, 1/3 of which it could be absorbed by military owned land. As we said, that's from 2019 data. So we are looking at air platforms, sea platforms, land platforms, stationary assets, and land sequestration. Okay, so look at this flow chart here. Defense emissions come from military platforms, stationary assets, and emissions sequestered by military owned land. And platforms are supply chain emissions, emission factors, and bill of materials. So this is armed forces scope 3 upstream emissions, scope 1 plus 2, and scope 3 upstream. Okay, I again did a stupid thing and forgot what OEM is, and I'm again going to do a stupid thing and look it up while I'm recording. Don't do it this way, but since I'm doing this voluntarily when I find time, you can hopefully excuse me for doing it this way, right? It's okay. They just say, see, it's always an issue, and they just use OEM as something we should just know without defining it. Other emissions, see, it's not defined in the document, so maybe it's some standard jargon that what is OEM in defense? I don't know how to search for it. Defense OEMs. AI is always original equipment manufacturer. That's scope 1 and 2 and 3. So MR, okay. Original equipment manufacturer. There you go. Why the report doesn't define it? Because maybe it's considered so standard that everybody knows it except non-defense people like me, right? Okay. So when you talk about scope 1 and 2 and 3, you know that you have materials coming to you, manufacturing happens, production happens, that's scope 1 and 2. Then when it's shipped out to operations, that's scope 3. So that's what they are talking about. Operational emissions, operational emission factors, and operational parameters. This is part of this. And then you have overall defense emissions coming from stationary assets and emission sequestration. So energy sources, emission factors, local regional energy mix and energy requirements. So this is armed forces scope 1 plus 2. And you have emission sequestration by military owned land, land sequestration profile, land type region, land type by region, military land by country. So they get into these details. Obviously, we have talked about nature-based solutions and nature-based CO2 removal, technology-based CO2 removal, and so on. So each one of these is amenable to those. So having these details matters. So here we are looking at emissions and how they add up from various platforms. So I won't go into the details, but you have to basically add up to the percentage emissions and different components of the emissions. So Air Force, Navy, Army, other with air platform, sea platform, land platform, and so on. So military emissions excluding the sequestrations on their land, and you have going down land sequestration and total military emissions resulting in about 1% of the total global emissions. So you have percentage of total adding up and the subtract yeah from the land sequestration to result in the 1% that we keep talking about. So defense's share of global emissions is comparable with that of civil aviation and maritime transport. However, military emissions could contribute up to 5% of the global footprint based on how you estimate them, but also transparency could be very different for civil aviation versus military, so how we estimate them is going to be very tricky as well. Okay, so the contribution of defense to global emissions is comparable to the contribution of civil aviation and maritime transports, as we just read. So if you look at sum of global emissions at 46 gigaton CO2 equivalent, so you have road, energy production by residential buildings, mining, so you have livestock and manure up here adding up certain percentages, and then other sources estimate defense emissions could be as high as 5%. So that is the global emissions coming from other sectors like civil aviation, maritime transport, but also you have fertilization of agriculture soils, production of oil and natural gas, energy production. Essentially, we are all in this together. Everybody has to head towards net zero. Defense is something that is an inevitable part of human societies. So you have to track their emissions and see how they can be brought to net zero as well. So it's not to blame anybody, but it is to have a good sense of where, as a whole, we are producing emissions and what the levers are in each sector. Agriculture has to do it, water, energy, health, buildings, everybody has to go to net zero, and military is what we are looking at here, right? So 70% of the military emissions are generated approximately by mobile assets. So here is the number, 520 million ton CO2 equivalent. Emissions from stationary, mobile, and operations. We already looked at it, but just re-emphasizing it. And we are looking at air, sea, land platforms. This is just splitting the previous figure into more details. This is for 2019. So other numbers coming from in-service platforms, active platforms, operating time per platform in hours per year, emissions per hour of operations in terms of tons of CO2 equivalent per hour. Why do we need such details? Because each of this detail will tell you where the emissions can be reduced, what are the low-hanging fruit, and what are the hard-to-abate emissions, and so on and so forth. Newly delivered platforms annually, typical mass of one platform, supply chain emissions per unit mass in terms of tons of CO2 equivalent per ton of supply chain. Okay, operational emissions and supply chain emissions, that's how they are split. So these are illustrative numbers, so there are some details on how these are estimated, but it doesn't matter. I want you to get out of this the details into which this report goes to track the defense emissions. We'll look at potential solutions in a minute, so this is important to look at first. Zoom into the US and UK defense emissions. US probably is the largest military force. Maybe China comes close, or maybe China is exceeding by now. UK obviously is part of the NATO and a friendly country to US and other NATO members. Whilst emissions from defense is a global problem, their drivers and potential mitigation actions vary by country. As an example, we zoom into the US and the UK. So here we go with the potential solutions. The US has the biggest military in the world, there we go, and we estimate that the footprint of its stationary assets and platforms operations account for 20% of the global defense emissions. So defense total is 1 to 5%, out of which 20% could be coming from the US, roughly 110 million tons of CO2 equivalent. Meanwhile, we estimate that the UK's armed forces produce 5 million tons CO2 equivalent, which translates to about 1% of the global military emissions. So you can see how much smaller it is. The two countries have in common that their emissions profiles are dominated by the operations of mobile platforms, 80% of the total, while stationary assets are responsible for about 20% of the emission footprint. These figures result from our estimations for 2019, and both emissions and the share of the total defense footprint could increase in years in which the countries have a more intense military activity. So they are almost, they are so close to each other, the two countries, and they support each other in every mission across the world, whether it's Israel or Ukraine or whatever, right? So they can be counted together here. There are some little points made that I'm skipping here. That's not so important, but here, nations. Sorry, those are just footprints. UN's Intergovernmental Panel on Climate Change is what IPCC is. Okay, so Roland Berger's estimates are broadly consistent with other sources, and discrepancies in the specific emissions figures could come from the sources such as modeling approach and emissions. So obviously there are uncertainties in these. Despite discrepancies in the figures, the intrinsic value of producing national defense emissions profiles is that they provide a high level indication of the areas on which emissions mitigation initiatives could have the highest impact. So levers where you can pick the low-hanging fruit easily to reduce emissions, and then go after hard to reduce, mitigate, abate emissions. Okay, zoom into the US and UK defense emissions confirms that the operations is the main contributor to these countries' footprint, as stated by different sources. So they all agree. So global defense emissions, we already looked at the numbers and the various contributions from stationary and non-stationary platforms, and you are looking at US and UK. So 110 million ton CO2 equivalent, mostly coming from operations. Same for UK, 5 million ton CO2 equivalent, 1% of the global total, 20% of the global total. Stationary assets add about 20%, 80% comes from mobile asset operations. Could be aircraft carriers and tanks, everything, right? So this is different data, Brown University and UK MOD, so they all differ a little bit, but as we said, the uncertainties come from different ways of estimating and modeling these things, but potential solutions should all lead to net zero in the end. A broad range of levers are available to decarbonize military operations, mainly focusing on less emitting platforms, improved stationary assets, and land management. Defense industry decarbonization levers, I won't go into the details, but here reductions of emissions from platforms, transition to more fuel efficient platforms, development and adoption of sustainable fuels, investigation and adoption of lower emission operation platforms, and research of non-CO2 emissions impacts. So examples, of course, design and procurement, prioritization, optimization on military air traffic, investigation on air platforms. So you imagine you are an Air Force and you have a bunch of very inefficient, let's say, fighter planes that pilots have to be trained and mission sorties have to be flown to test yourself, be ready, and so on. How do you optimize those? Are you going to optimize those based on net zero and sustainability, or are you going to optimize them based on other economic and threat factors? Obviously, it will be the latter, right? So, mitigation potential is high for transition to more fuel platforms, lower for development and adoption of sustainable fuels, investigation and adoption of lower emission operation platforms, and research of non-CO2 emission impacts. But the main point is that militaries have often funded research, secretly or not, to deal with their problems, and many of those innovations have led to amazing discoveries like the internet and drones and other things. So there is some co-benefit that comes out of these as well. Advantages, of course, reduction in operating costs is a co-benefit, and similar things, increase in the stealth level of Air Force operations by avoidance of short-lived and persistent contrails by going to CO2 emissions. So basically, avoiding radar signals by reducing heat and emissions, right? So other reduction emissions from military stationary assets. So these are from platforms, stationary assets, leverage of military and military land for carbon sequestration, shift to green energy for military facilities, and switch to low carbon internal logistics. These are the low hanging fruit, for example, and they have significant mitigation potential as well, with associated co-benefits such as reducing logistics cost due to fuel savings, acquisition of experience certifying platforms for operations with new fuels, and so on and so forth. The supply chain can put a dent in the operational emissions by designing less emitting platforms whilst decarbonizing its own activities in raw material and equipment production. Right? So here's in the supply chain, you have in the design and raw materials and manufacture, as well as resources and logistics, and I think that's, yeah. So again, you have transition to more fuel efficient platforms in the design, optimization of raw material production, transition to circular approaches, so end-to-end use of material, reduction of scrap in manufacturing processes with various levels of emissions and operational, so supply chain emissions and operational emissions. That's how they are looked at here. So you know where to mitigate, where the mitigation potential will come from. For resource and logistics, you have progress towards resource efficient production sites, shift to green energy, and switch to low carbon logistics. So technology innovation may be needed, but many of these things are already available at high technology readiness levels. So here are supply chain and operational emissions as well. Most of them don't have operational emissions in the resource and logistics, but here design has a lot of operational emissions as well. So it matters, and the filled circles and open circles have high mitigation potential and low mitigation potential. That's how we want to look at it, not the way I said it. Okay, sorry. Okay, so low mitigation potential, high mitigation potential, low, high, low, medium, low, medium, low, and low, low, and higher than here, but basically low. Okay, the transition from metallic fighters to composite jets has contributed up to 50% reduction in operational emissions at the expense of 30% supply chain emissions increase. So they are not optimizing for net zero or sustainability, they are just optimizing for lighter, faster, more efficient, fuel efficient, and maneuverability, and so on and so forth. So previous generations, new generations, these are specific aircraft, so let's not go there, but there are reinforced and titanium, composite reinforced, and so on, and steel and aluminum. So obviously they have moved into also reducing supply chain emissions, which have gone up with newer materials, but operational costs have gone down by various levels, which makes sense. Okay, what is the way forward? The defense world is waking up to the profound influence of climate change and its potential to become a multiplier for conflicts. So militaries are also tracking where new hotspots of conflicts may arise from, or terrorism and so on, because of climate impacts. So climate itself is a national security threat now, and that may justify more spending on defense, but then again you have to come back to reducing emissions and driving defense to net zero, right? So the defense world is waking up to the profound influence of climate change and its potential to become a multiplier for conflicts, as military leaders acknowledge that global warming and its effects can devastate communities and fuel tensions. Some armed forces have started to take action towards reducing their emissions footprint. In 2022, the US Air Force introduced the department's Climate Action Plan, and at the opening ceremony of last year's NATO summit in Madrid, its Secretary General announced an organizational cut in emissions for its members by 45% by 2030 and a net zero target by 2050. You go. The UK's Royal Air Force has set an even more ambitious target, committing to achieve net zero by 2040. Its Air Chief Marshal also instigated the formation of the Global Air Forces Climate Change Collaboration, which brings together 40 air forces in 6 continents to share best practices, lessons learned, and the ideas to fight climate change. So if they can share share information with enemies, it could all be good news. But remember, monitoring, reporting, evaluation, so transparency is going to be critical, because every time there is a threat, militaries are going to shut down the information flow, right? With the high level of commitment to become more sustainable, defense industry stakeholders should assess the portfolio of decarbonization levers available to their organizations and identify the options with the best emissions savings potential in the short and mid-term, as they prepare for a future that will bring a shift in the paradigm of military platforms. For example, transition from current generation of fighters to the NGAD, GCAP and FCAS and so on, which you can look up. For example, they are next generation air dominance, global combat aircraft program, and future combat air systems. So they are in development on both sides of the Atlantic. With that shift, the sector has the possibility not only to achieve higher performance from its platforms, but also to embed sustainability as a competitive advantage into them. So if militaries see some advantage, they're going to go after it very aggressively compared to the civil sectors. Defense suppliers and industry participants should understand their emissions baselines and plan out a set of actions to reduce emissions in a targeted way. For example, make avoiding emissions from operations an integral part of the design process, ensure sustainability of supply chains. Moving equipment to conflict regions is a massive operation and is something where militaries will be happy to reduce weight, fossil fuel cost, and so on. Not necessarily focused on emission and sustainability, but just focused on operational efficiency and effectiveness, and that will have co-benefits, of course. Ensure sustainability of supply chains, make avoiding emissions from operations an integral part of emissions planning processes, identify how sustainability and operational effectiveness can strengthen each other, decentralized energy generation, understand the broader impact of actions taken, for example, given scrutiny from investors and other stakeholders on ESG, which is environmental, societal and governance, right? Environmental, societal and governance. Okay. So conclusions: the defense industry, representing 1 to 2% of the global emissions today, will be one of the most difficult to decarbonize. Mitigating the more than 500 million tons of CO2 equivalent generated annually by the sector, most of which stems from the operation of military platforms, must not come at the expense of operational effectiveness, because if it affects effectiveness of operations and defense readiness, then defense industry will ignore it. But using the main using the many levers available to them, end users and their supply chains can drive evolutionary and revolutionary change, improving efficiency, reshaping operations, and switching to new technologies. Indeed, the concept has already been demonstrated through the transition from mainly metallic airframes to composite aerostructures for combat aircraft, thereby reducing fuel consumption and therefore emissions whilst simultaneously improving performance. So their focus is something but can have co-benefits for climate and net zero, sustainability, etc. At a time when the effectiveness and value for money of defense is firmly in the spotlight, we need decisive and collective action to drive a critical change. So collective action on the climate action side is one thing, but if you're trying to do this on the military side, it again comes down to how much information militaries may actually share at all, because they want to have an advantage all the time. So if sharing information compromises that advantage, then they're not going to share, right? So nobody is going to say, let's all go to net zero and still maintain advantages in the battlefield. So we need intelligent ways of sharing information and making these things happen. Okay, so see you in the next topic, which will be another report on defense emissions and so on. Okay.